Okay, we can start. Hello. Today we will make the solutions of the round 932. Okay, let me wait the comments. So I will be sure that we have started. Let's wait 4 minutes. So we will start at 40, 740. Okay, I will wait for 2 minutes and I will start at 40, 740. Let me open my whiteboard. Okay, I think we can start this 40 now, 740. Uh, I hope the contest was well for you. Let's start, let me begin with the problem A, and we will continue up to problem D, A, B, C, and D. Let me open the problem A. Okay, in this problem, it said that there is a string S and even integer n. Uh, in the contest, I did not read this even. So My code is a bit long. Okay, let's continue. We have a string s and even integer n. We have two operations to apply. First one is the reverse string s. Sorry, first one is add the reversed string to the end of the s, reversed version of the s to the end of the s. And the second operation is to reverse the string s. So if the string is CPM, string will be MPC. If we do the second operation, and if we do the first operation and the string is CPM, the string will be CPM MPC. Okay, it's the question. The problem wants from us to find the string that is lexicogeographically the smallest after applying exactly n operations. Okay, the lexicogeographically smaller string means if a is prefix of b, but a is lexicogeographically smaller than b if a is prefix of b, but a not equals to b. And if the first position where a and b differ, the string a has the letter that appears early in the alphabet. This means lexicogeographically smaller means alphabetically smaller. I mean, if one string is ABC and this other one is ACB, this one is smaller. Okay. Firstly, I have thought in this question, I have thought that, sorry, let me open the correct question. Let me close these ones and open the correct one. Okay. I have thought that if we will do two n operations, but n is even, so 2k operations, we can uh, apply first operation or second operation. But uh, the smaller string is lexicogeographically smaller. So I mean, if we have a string like CPM, or if we have a string like CPM, A, this is lexicogeographically larger than CPM. So the smaller string is better than the a bigger string. But there's a case like this. If we have a string like, let me think, BA, we need to reverse the strings because AB is smaller than BA. So we should reverse this string to in order to obtain a lexicogeographically smaller string. So we should reverse this original string and apply operations on the new string, on the reversed string. So we will do one operation. I mean, if the reversed version of our string is smaller than our initial string, we should reverse the string. And we will make one operation to reverse our initial string to obtain the reversed version. And so we will have n minus 1 operations. N minus 1. N minus 1 operation will remain. So what should we do? We can, this is odd number. Let's say 2k plus 1. We can reverse our string for 2k times. Like we can do BA again. Then we can do AB. This will take two operations. So we can obtain AB in 2k operations. But n is odd, so it is 2k plus 1. We have one operation to do. What can we do? We can do the first operation. So we can do the string ABBA. So therefore, we should do an algorithm, a method like this in this problem. First, if our string is smaller than the reversed version of it, like AB, we can output it easily. But if our string is larger than its reversed version of it, like BA, we should reverse it. We should do AB, and we should add the reversed version of this string, ABBA. So if the string's reversed version is smaller than it, the initial version of the string, we should output like this. Else, we should output the original string. Let me open the code. I have made two cases in my code, but the else is unuseful, useless in my code because it says n is even. Okay, let's only look this place. I said ss equals to s, and I reverse the string ss. Then if s is smaller than ss, I have output the s. Otherwise, I have output ss and then s. It is our algorithm, what we watched. Are there any questions about this problem? You can ask from chat if you have any questions and problems. Otherwise, I will continue with the problem B. Okay, I think there's no problem. There's no question. So I will continue with the problem B. Okay, this is the problem B. Let's look what it asks. There's an array with length n. We should divide it into k segments, and k must be greater than 1. The max of each segment, each subsegment should be same, must be same. So here it says to divide the array to subsegments. Max is a definition that the smallest element, smallest non-negative integer, so, that do not belong to the array, does not belong to the array. Okay, like max 2 to 1 is 0 because 0 is not in the array 2 to 1. Or 3101 is the max of the 3101 is 2 because 0 is in the array, 1 is in the array, but 2 is not in the array. So the max of this array is 2. Maximum excluding elements, I think, the long form of this word, but I'm not sure. Okay, let's look to this problem. First of all, we should see. I think that in this problem, if I divide the array into the two segments, two subsegments, it is enough, or I should divide the array more than. Is there any case that I should divide the array more than two subsegments? I have thought about this problem, this question, and let's look on this question. First of all, think like 0, 1, 2, that is going, and there is a 0. If we divide the array from here, we will take this 1 and 2 with this 0. So we will take this 1 and 2 in the max in the future. So I have think that I should take the first of all I should find the max of the original array, and then the max of the subsegments must be same with the max of the original array. I mean, if the max of the original array is 3, each subsegment's max should be 3 too. Because think like 0, 1, 2, something else, 4, 4, 4, 4, 5, 4, 5, 0, 0, 0, 1, 0. Okay, let's look on this case. If we choose this 0 and 1, we are trying to obtain an partition that the max of a subsegment will not equal to the max of the original array. If we take 0 and 1, we will take this 2 for in the another array, and we know that all the maxes should be equal to each other. So if we take 0 and 1 in this subsegment, we should take 0 and 1 in another subsegment. And all subsegments we have divided. In all subsegments we have divided. So if we put 0 and 1 to each subsegment that we have divided, and this 2 will go to any segment, because each element should go to one segment. So this 2 will be in some subsegment, and each segment contains 0 and 1. So a subsegment, any subsegment, one of the subsegments, at least one of the subsegments will contain 2. So each of them is containing 0 and 1. So at least one of them will contain 0, 1, and 2. And the max of this array is 3. So the max of at least one subsegment should be the max of the original array, and the max of the max of one subsegment is equal to max of the all subsegments. So max of each subsegment should be equal to max of the original array. Okay, after this observation, we know that the max of the one subsegment should be equal to max of the original array. So in the problem, I solve it like this. First of all, I find the max of the array, max of the original array. Then I choose the smallest subsegment that starts from the first element, and this max of it equals to the max of the original subsegment, original array. Let's think about this sample. We saw that this is the first place that the max of the array is max of the subsegment is equal to max of the array. Let me change the input a bit. Let me make this one place 2. Okay, we can choose this subsegment 2. Its max is also 3, but I am choosing the smallest subsegment. So I choose this segment, this subsegment. After that, I am looking to the remaining elements. The max of the remaining elements should also be the equal to the max of the original array and max of this subsegment. So let's look on this code. I have solved the problem like this. First of all, I have read the array, and I have created a priority queue. And in this priority queue, I am collecting the elements from small to large. So I am pushing the elements in negative order. This gives, when I say priority q nokta top, it gives the smallest element to me. In the normal priority queue, it gives the biggest element in the array. But uh, I have solved, I have pushed the elements with negative order. So if a number is greater than another number, it's the negative version of it is smaller than the negative version of the other number. I mean, if we have 3 and 1, 3 is greater than 1, but minus 3 is less than minus 1. So now my priority queue is giving the smaller element on the top. Okay. After that, I said while priority queue is not empty and priority queue's smallest element, I mean the smallest element that is going to ith element is if is it is less than x. X is represent the max in our array because x starts from 0, and when we find x, I am increasing the x. So x is increasing when we find the x. So x gives the max of the current max. After that, I am increasing while priority queue's smallest element is less than or equal to x. I am deleting from the priority queue, and if equals to x, if it is equals to x, I am saying that I am increasing the x and I'm saving the I value, because this means the max of the original array is from 1 to I. So 1 to int. It will give in the final operation, the int will give the index that the original array's max is going from 1 to where? It's going from 1 to int, the smallest subsegment. The last element of the smallest subsegment, that's max is equal to the max of the array. After that, I'm clearing the priority queue. This is for max can be 0, and I'm starting the int from 0. So if max is 0, I'm making int to be 1, because the arrays should have positive length. So it must be greater than 0. So I'm maximizing it 1 here. After that, I am declaring an element y. It's initially equal to 0. Y is giving the max from int plus 1 to n. So I am also pushing the priority queue, and I'm using the same method to find the max. I'm taking from the priority queue, and if it's equals to y, I am increasing y. So in the end, if y is not equal to x, this means the max of the left part is not equal to max of the right part. The max of the left part is equal to, not that left of the max of the left part is equal to max of the array. So if max of the left part and max of the array is not equal to max of the right part, then we should output -1. Otherwise, we can output 2, and we can output from 1 to index, and from index plus 1 to n, because we have only 2 intervals and we are outputting it. You can solve the problem with another method, because there are many methods to find the max. I have used this technique, but it's okay if you used some other technique. Okay. Are there any problems about this problem? Are there any questions about this problem? You can ask from the chat if you have any problems, any questions. Please feel free to ask your questions. Okay, I will wait a bit and I will continue with the problem C. Okay, let me there are many techniques for finding the max. Uh, there are, I don't know if there are any other techniques to solve this question, but there are many ways to find the max of an array. Let me think. You can sort the array. You can create another array, and let's say B. You can sort the array B, and after sorting the array B, you can find the max from the sorted array. Finding finding the max from sorted array is quite easy, I think. Okay, I will continue with the problem C. Let's look to problem. There are n messages. And each message have two numbers, AI and BI. Time. Okay. If you read the numbers, the messages, P1, P2, and PK in this order, BI are all distinct. Your time that you have spent, the time that you have spent will be sum of the APIs plus 1 to k plus sum of the differences between BPI minus BPI plus 1. So this is the formula that you have spent your time if you read the messages, these messages, and in this order. Okay. Okay, if you read only one message, your time will be AP1. If you read only the message P1, your time will be AP1 because here the score will come AP1 and here will come 0. So it will be totally AP1. If you read 0 messages, your time will be 0. Okay, you have only L minutes to spend in the messenger. So the problem asks to us to find maximum number of messages that we can read in the L minutes, not without exceeding L minutes. So we have only L minutes and we want to read as many messages as possible. Okay, if we cannot read any messages, our score will be 0. Okay, n is smaller than 2000. Okay, L is smaller than 1 billion. In this problem, I have solved the problem like this. First of all, I think that taking the, let me clear here, taking the elements in an order with like random BIs is nonsense. I mean, if we take B1, B2, B4, B3 in this order, if we read the messages in this order, B1, B2, B4, B3, and if they equals to 4, 5, 2, 3, we are using we are using our time in a bad way, because we can optimize our time with rearranging these numbers. Because if we read the messages 1, 2, 3, and 4, we can change the order without looking to A's, because we are always summing up the A values. The order of the messages do not change the A values. So if we read in this order, the value that comes from A's will be A1 plus A2 plus A3 plus A4. If we read the messages in order like 1, 2, 3, 4, we will spend A1 plus A2 plus A3 plus A4 minutes for A's. So A's are not changing when we change the order. So only the B values, the second part of the summation, changes from the order. So after this, it is nonsense to order the elements like this. So the best way to order the elements to decreasing order, in decreasing order, or non-decreasing order, or increasing order. I mean, if we order these numbers like 5, 4, 3, 2, we will only add 5 minus 4 plus 4 minus 3 plus 3 minus 2. And this 4 will go, this 3 will go. We will only we will only spend 5 minus 2 minutes. But in this case, we will spend 5 minus 4 plus 5 minus 2 plus 3 minus 2. And this means 1 minute from here, 3 minutes from here, and 1 minute from here. And it will be 3, 4, 5. We can do it with 3 minutes, but if we order the numbers like this, we need to spend 5 minutes. So ordering like this is better. Okay. So we can sort the numbers and sort the messages with looking their B values, because as we said, A's are not changing from order to order. So the only B values affects from the order. The second part is affecting from the order of the messages, and the second part looks to the B values. So we can sort the messages like looking to their B values. So we will sort the messages with looking their B values. After sorting the messages, we should look how many messages we need to, how many messages we can read. To find it, if in some question you are looking to how many messages I can read, and if you can read 3 messages, if you can read 4 messages, you can also read 3 messages, and if you if you read 4 messages, if you can also read 3 messages, 2 messages, and 1 messages, and also 0 messages, you can use binary search on answer method, or binary search on answer technique. So we will also use binary search on answer technique in this problem to find how many messages we will read. And we only need to check if we can read middle messages. I mean, if I will say middle to the left value of our answer and the right value of our answer. I mean, this left means the smallest value that answer can be, and right means the maximum number that answer can be. Middle means L plus R divided by 2. So we will look to middle values, and we need to check if we can read middle messages or we cannot read middle messages. We need to look to this, we need to check this. So how can we check this? I have checked this like this technique. First, I will say x to middle because x is smaller, short, only one character. Okay. I am checking x value. I'm saying if I can read x messages or I cannot read x messages. Okay. First, I will choose a starting point from 1 to n. I will choose a starting point, let's say L to it. I will choose a starting point and I will try all ending points. I will try all R values so that I will choose exactly X elements from L to R. I will choose some elements from L to R, and the number of the chosen elements will be X. And I am trying to minimize this summation, minimize the spend time. To do this, I have used a technique like this. I'm increasing R one by one. I am first of all I am selecting L value and I am increasing R one by one. So when a new elements come, what should I do? R will always be same. So for the second part of the summation, I will add in this for this interval, for the interval from L to R, I will add BR minus BL. Because what we said, if we sort the array from in increasing order, and if we read the messages like this order, B1, B2, B2, B3, BK, we are adding B2 minus B1 plus B3 minus B2, and finally plus BK minus BK minus 1. So these B2s are going, these B3s are going, this BK minus 1 is going. So in the last, the only BK minus B1 is remaining. So we can, if we choose the interval from L to R, we can add for the second summation this value. We can add this value for the second summation, BR minus BL. Also, we need to look for the first part, sum of APIs. So it is better to choose smaller a values. I mean, if we have 1, 2, 3 in from L to R, these are a values. If we choose 1 and 3, it is nonsense. So we should choose 1 and 2, because if we choose 1 and 3, the sum will come 4. If we choose 1 and 2, the sum will come 3. So I need to find the minimum x elements from L to R. Minimum x elements from L to R. And I'm increasing the interval 1 by 1. I'm increasing the R value 1 by 1. So I will use a method like this. First I will look to an starting interval from L to L, comma, L plus x minus 1. There are exactly x elements in this interval, L to L plus x minus 1. There are exactly x elements in this interval. And I will push each element in this interval to the priority queue in the initial case. When I increase this value and when I lengthen the interval, I will get L, L plus x. So there are x plus 1 elements. So there are one more element, but I need to choose x elements. But I know the elements, the biggest x elements, because I pushed them to the priority queue in the first case, in the initial state, first state. When I am looking to this state, I only look to the new element that come. I will look to L plus x. And I need to compare this element with the elements that are in the priority queue, that are in the maximum x elements. So if I need to look to this, element and the other elements, the other biggest x elements, I only need to compare the biggest element in this interval, the biggest element of this x number, and on this value. So if this value is smaller than the biggest value of this x numbers, so I can delete the biggest number in this x numbers, and I can push this value because this is smaller than a number in this x elements, and this priority queue gives me the smallest x element from L to R. So if I find an element that is smaller than any element in the priority queue, I should delete that element from priority queue and I should push this element to the priority queue. So I can find the smallest x elements from L to R in any case. Let us look to the code and understand more clear. Okay. First, I have sort array looking to the b values, because this is the first of the pair and this is the second of the pair. So I am sorting pair. So it is the sort algorithm looks to firstly. Okay, and I'm starting a binary search on answer. This is the minimum answers that can be, and this is the maximum answer that can be. So after that, while the smallest answer is smaller than equal to smaller or equal to smaller than or equal to the biggest answers that can be, we are doing the binary search algorithm. So we are checking this ORT. This ORT means X that we looked in this board. So in this code, ORT means X. This for is going from 1 to n. I said if I plus x minus 1 is bigger than n, then I cannot choose x elements from I to n. There are no x elements because it is crossing the border. So I can't choose x elements. I should break the for loop. After that, I am creating a priority queue, and the first answer is the first answers for that comes from the second part of the summation is pi plus x minus 1 minus pi. The phi means first, and first means b values of the messages. After that, I'm going to I to I plus x, smaller than I plus x. This means I am taking an initial and starting interval with x elements, with ORT elements in this variable name, with this variable name. Okay, I am pushing the values to priority queue, and I'm adding their a values to the answer. And I'm saying if answer is smaller than or equal to L, this K is L in my code. You can look from here. K is L. K means L. If answer is smaller than L, I am breaking because I can say I have found an interval. I have found some messages, some exactly X messages that their summation is smaller than or equal to L. The problem wants the thing that problem wants is also this. So if I find this, I can increase the L value in the binary search, the start value, the starting value. Yani, I mean the smallest answer that can be. We should increase it, the smallest value that can be. Okay, I'm going from this value to n. So I am increasing the r, the variable r. This j means r. Okay, I'm saying if priority queue dot top, the largest element in the priority queue is greater than our current element, the arts value, jth value, uh, the we are looking to a values, not that. Okay, what will say? We should erase from priority queue, and I'm also decreasing the answer by the value that comes from priority queue. I am erasing from priority queue, and I'm pushing the new element, the current element, to the priority queue. Priority queue dot push pg dot second. I am pushing the new a value, the new coming a value to the priority queue, and I am adding this value to the answer. Also, I am adding pg dot first minus pj minus 1 dot first because I have increased the length of the array. I have increasing the r value, so the new value that comes from the second part of the summation will be pg that will increase with this value because I have increased the interval. So the answer that comes from the second part of the summation will increase like this value. Also, I'm saying if answer is smaller than or equal to k, break. And I'm also saying if answer is smaller than or equal to k, break. And in here, I'm saying if answer is smaller than or equal to k, make the smallest answer that can be bigger, increase the value that the answer, the minimum answer, increase the minimum answer, otherwise decrease the maximum answer. And finally, I am outputting maximum answer. This I have solved this problem with binary search. Okay, are there any questions about this problem? If you have any questions, you can ask. This was the problem C. Okay, you can ask your questions if you have. Otherwise, I will continue with the problem D. Okay, I think there are no questions. So I will continue with problem D. Okay, in this problem, it says there is a set S and with size n and some integer c. We need to count the number of pairs x comma y. That's 0 is less than or equal to x, less than or equal to y, less than or equal to c, and x plus 1, x plus y is not in the set, and also y minus 1, y minus x is not also in the set. You need to answer the question. You need to answer this question. Now let's continue with the solution of this problem. Okay, it gives n and c values and n elements. This is the array this is the set that they have given to us. Okay, we should look to this set that we are looking when x plus y and y minus x. Okay, so firstly, I have think that okay, let's open another place. Okay, firstly, I have think that I need to choose x value and also y value. And x should be less than or equal to y. How can I solve? How can I choose these values? I can choose the x 1, 2, 3, c and c. I can choose the y 1, 2, 3, and c. So I know that x plus y should not be in the set, and x minus y should not also be in the set. So if we add these values, x plus 1, x plus y, and x minus y, we will add 2x. Let's say x plus y is equal to k, and x minus y, okay, let's say minus y minus x. Y plus x equal to k, and y minus x equal to m. Let's add these values, sum of these values, then we will see 2y will equal to k plus m. So if we choose the k and m values, like one of them will be odd and one of them will be even, this sum will be odd because the sum of odd and even number will be odd. So if this sum will be odd number, and if we say 2y is equal to odd number, y will not be an integer because odd number cannot be divided by 2. So we know that if k is odd and m is even, or k is even and m is odd, then y will not be an integer. So we can observe that if k is odd, then m is also odd. If k is even, m is also even. Okay. After this observation, we can, in order to choose x and y values, we can choose x plus y and x minus y values. Sorry, y minus x values. It is not important, but it says y is greater than x, so let's write y minus x. Okay, we can choose x plus y and y minus x values, because if we choose x and y values, the x plus y and the y minus x values are unique. So, if we choose x1 y1 and x2 y2, either their sum will be different or their difference will be different. So we can look to in how many ways we can select these values. Okay, let me write like this, y plus x. Also, we know y minus x is smaller than or equal to y plus x. This can be from 0 to c. This can be from 0 to 2c, because y plus x can be 2c. C plus c can be 2c. Okay. But c is too big. It is 1 billion. So we cannot iterate on the values of c. We need to do something else. Let's look on a sequence. Okay. If we choose y minus x equal to c, we can only select y plus x c, because if this value should be greater than or equal to this value. Also, if we choose c plus 2 in this case, their sum will be c 2c plus 2, and we said that 2y is equal to this value, and after that y will be equal to c plus 1, but y should be in this interval, should be bigger or equal to 0 and smaller than or equal to c. So this equation cannot be held to the question for the problem. So if we choose the y minus x as c, we only select y plus x as c. So there is only one possible case for C. Let's look to C minus 1. If we choose this C minus 1, we can choose C minus 1 here, in here. Let me clear this. Okay. We can select C minus 1 here for y minus plus x. We can select C, because if we select C, then their sum will be odd, and we will set 2y is equal to an odd number. So we cannot select C. We can select C plus 1, because C plus 1 plus C minus 1 will be 2C, and when we divide it to 2, we will gain C, and C is smaller than or equal to C. So there's no problem. So if we choose C minus 1 for y minus x, we have two possible cases. Let's look C minus 2. Okay. In C minus 2, we can select C minus 2. We can select C. We can select C plus 2. Because C plus 2 plus C minus 2 will 2C. So we can select. So there are three cases. Let's look for C minus 3. C minus 3. We can select C minus 3, C minus 1, C plus 1, C plus 3. So we have four options. You can see that it is increasing like 1, 2, 3, 4, and when we select 0, it will be C plus 1. So if the set would be empty, our answer will be C plus 1, the sum of numbers from 1 to C plus 1, and it equals to C plus 1 multiplied by C plus 2 divided by 2. But there are some elements in the set. So we need to take care of them. Okay, I cannot delete this. Okay. Okay, let's continue here. How can we look to that values? Okay, if we saw an element x, k in the set, it can either be x y minus x, or it can be y plus x. Firstly, let's think it is y minus x. So let's think y minus x is equal to k. How many numbers we should decrease from our answer? Let's think. We said that if a number is k, and it equals to C minus M, then the answer will be M plus 1. Let me think. Yes, because in C, we said there is only one option. In C minus 1, we said there are two options. So C minus M, if K is C minus M, and let's think K is C minus 1, then the answer, the possible options for x plus y is m plus 1. So we can decrease m plus 1 from the answer for the choosing k as y minus x. Okay, let's look to the other case. I mean choosing k as y plus x. So in this case, if we choose the k as y minus y plus x, we know that y minus x should be smaller than or equal to k, and also we know y minus x should be smaller than or equal to 2c minus k. Because if this value is greater than 2c minus k, we will add k for y minus x, and 2y will be greater than 2c, and y will be greater than c. And we don't want to y will be greater than c. So we need to look how many numbers that corresponds to these equations, and sorry, I need to write like this. Okay, and we can check it easily. Let's look on this code. Okay, firstly, I have scanned the numbers, read the numbers. After that, I have said that answer is equal to. I have thought like it is empty set, and the answer is k plus 1 multiplied by k plus 2 divided by 2. It is the sum from 1 to k plus 1. The formula that gives summation from 1 to k plus 1. Okay. After that, this odd means the number of odd elements that comes from 1 to I, and even means the number of even elements. Okay. This is this part is choosing AI as x plus y. So I have increased odd. If it is odd, I have increased odd, and I have uh, decreased the value, decreased the answer as the minimum AI plus 1, and k multiplied by 2 minus AI plus 1 by divided by 2, because if the number is 4, if x plus y is 4, then there's two even numbers that y minus x can be. It can be 0, 2, 0, 2, sorry, we said odd, 3. It can be 0, 1 or 3. So there's only two options. So I'm adding 1 and dividing by 2 to find the number of odd numbers that y minus x can be. And I'm decreasing this value by the number of odd numbers. This is because we can select x plus y as k and x minus y as k. There are some collision situations. So in order to take care of collisions situations, I'm decreasing odd in this case by choosing uh, x plus y is equal to k. I am decreasing because I am also adding some cases in this case, and I am also adding in this case. So I need to decrease this by the number of odd numbers, because if otherwise I will add the collisions twice, and I don't want to add the collisions. I don't want to decrease the collisions twice. Okay, this is why I'm doing like that, and adding I'm decreasing AI plus 2 and k multiplied by 2, decreased by AI and add 2, because I'm adding 2 in this case, because think 4 as x plus y minus x can be 0, 2, and 4. So there are 3 options. So I'm adding 2 and dividing by 2. This is why I'm adding 2, because this we should also remember 0 case. 0 is also accepted in this question as a number. And this case is choosing k as y minus x. Okay, I'm saying if this is odd, then k minus ai is odd, Let me look. By the way, it is useless. This if and else is useless. They are decreasing the same value. Okay, we are in the both case we are decreasing k a k minus ai plus 1. We said if m is equal to k k c sorry c minus k, then the answer will be m plus 1. So we are decreasing this value. This is the value for choosing k as y minus x. So we should decrease from our answer. And I'm outputting the answer. So did, what we what we did in this question, in this problem, we first think like an even set and find the answer for an even set, and for the elements in the set, we we have decreased the answer and we find the correct answer. We found the correct answer and we have outputted. This is the solution for this problem, for the problem D. Are there any questions about this problem? Okay, let me look the chat. Uh, Dwinor, can you say what's the part that you have lost so I can help you? I can look to that part. I can tell that part again. Okay, how is k plus m equal to s equal to c? Because why we are adding 1 to add and 2 to even. Uh, it is because let me open the board. Uh, think like think the tree. Okay, tree. How many odd numbers smaller than 3? 1 and 3. So I'm adding 1 to 3 and dividing by 2 equals 2. So we have found the correct answer. Think 4, or let's think 6. How many even numbers smaller than or equal to 6? 0, 2, 4, and 6. So I am adding 2 and dividing by 2. So this gives 4. This is the number of even numbers that are smaller than our number, our current number. Do you understand now? Okay. You can ask your questions. Please feel free to ask so that I can help you. I'm looking to chat for your questions. If you have not any questions, I will stop the stream. I will finish the stream. So I'm waiting a bit for your questions. Please, as I said before, feel free to ask. Oh, okay, let me wait 1 or 2 minutes for your questions. Please ask your questions if you have, or as I said before, I will finish the stream. I'm waiting for you. If some points is not clear for you, please ask them. Yes, we are decreasing. We are decreasing. We are subtracting the present values. We are subtracting the values that collapses with the elements in the set, because we are first selecting all elements in the empty set as x plus y and y minus x, but some elements are in the set. So what the problem says? Both x plus y and y minus x shouldn't be in the set, mustn't be in the set. So uh, if we find a value in the set, we are decreasing the value as choosing this value as kx plus y and choosing this value as y minus x. We are decreasing the both values. So we are finding the real value. Is it clear, Nilesh? Okay. If there are not any questions, I will finish. I will wait until 53. Thank you very much. Okay, it's 53. Thank you for listening me. I have really enjoyed from the contest and for this stream. I hope you also enjoyed from this stream and you have understand the solutions of the problems. Thank you again for listening me. So goodbye.